Imagine an AI that's dead certain about its answers, yet those answers are dangerously wrong, and it's costing lives, livelihoods, and trust in science itself. That's the scary reality we're facing today, and it's about to change. But here's where it gets revolutionary. A groundbreaking technique from a University of Arizona astronomer could make AI systems far more reliable, helping them admit when they're unsure. Let's dive into this story, exploring how it works, why it matters, and what's sparking debate in the world of tech and science. And this is the part most people miss. How a simple classroom moment led to a billion-dimensional breakthrough. Peter Baruzzi, an associate professor at the Steward Observatory, has pioneered this innovative approach. It's designed to tackle one of artificial intelligence's biggest flaws. Those bold, incorrect predictions that AI models churn out with unshakable confidence. From chatbots inventing fake facts to systems misidentifying faces or denying housing applications, these hallucinations, as researchers call them, aren't just glitches. They're causing real harm, like flawed medical diagnoses or biased decisions in criminal justice. Baruzzi's paper, currently under peer review, is freely available on AR14, that open-access hub for cutting-edge scientific ideas. He developed this method with support from a National Science Foundation grant for bold, exploratory research, the kind that takes risks for big payoffs. And now, the code is out there for anyone to use, empowering scientists globally to test it on their own projects. It's like handing out a toolkit for building smarter AI. The core of Baruzzi's innovation draws from ray tracing, a technique you're probably familiar with from blockbuster movies. Think of how Pixar animators simulate realistic light in films to create stunning visuals. Baruzzi adapted this for AI, turning it into a way to navigate the vast, intricate mathematical landscapes where AI models operate. For beginners, picture this. Ray tracing in movies follows light rays to render images. Here, it explores rays through the complex spaces of AI probabilities to spot uncertainties. His journey started in his own field of galaxy formation research. Baruzzi built the Universe Machine, a powerful tool that processes enormous amounts of telescope data to simulate how galaxies evolve. But he hit a wall. Traditional ways to handle uncertainty in these massive models just couldn't keep up with today's data overload. Galaxies involve countless variables. Think of all the factors influencing their shape, size, and behavior, and existing techniques fell short. But here's where it gets controversial. Could this method really transform industries? Or is it just another band-aid on AI's deeper flaws? The inspiration struck during office hours with an undergraduate student. The kid brought a physics homework problem about how light bends through Earth's atmosphere, simulating changes in light speed as it travels. That sparked Baruzzi's lightbulb moment. Why not extend ray tracing to a billion dimensions? Instead of 3D movie magic, he scaled it up for the ultra-high-dimensional worlds of modern AI, which deal with billions or trillions of parameters. At its heart, the method employs Bayesian sampling, a tried-and-true strategy in statistics for weighing uncertainties. For those new to this, Bayesian sampling is like polling a panel of experts. It tests multiple scenarios to gauge reliability, rather than trusting one voice. Traditionally, it's been too slow and costly for giant AI networks, but Baruzzi's twist makes it feasible. Instead of one AI model guessing, it trains thousands on the same data, exploring a spectrum of possibilities. If the experts disagree wildly on something novel, that's your cue. Don't trust the output. This approach is exponentially faster than old methods, slashing the time needed for uncertainty checks. The result? AI systems that hallucinate less, becoming safer and more robust. Picture a doctor using AI for a routine scan. If the AI confidently says cancer, despite no symptoms, you'd want a second opinion, right? Baruzzi's method delivers that, not just one AI verdict, but a range of plausible ones, highlighting when certainty is fake. The impacts ripple out everywhere. In medicine, finance, housing, energy, criminal justice, and self-driving cars, AI is increasingly making life-or-death calls. With this tool, systems could flag their uncertainties, admitting "I don't know" when needed. For scientists, it's a game-changer too. AI now aids in drug design, weather forecasting, black hole imagery, paper summaries, and coding. But those confident errors erode trust. As Baruzzi notes, This breeds skepticism in public forecasts and scientific breakthroughs, often requiring expensive double-checks. For Beruzzi personally, it's unlocking cosmic secrets. Instead of simulations mimicking our universe's stats, he can now reconstruct its actual starting points, like rewinding a movie of galaxy formation to see the Big Bang's aftermath in detail. No more fake universes, just the real history. And this is the part that divides opinions. Should we rely on AI for critical decisions at all, even with better uncertainty checks? Or is human oversight still essential? Some argue this method democratizes AI, making it safer for everyone. Others worry it might lull us into complacency, over-trusting tech that's still flawed. What do you think? Does this innovation solve AI's trust crisis? Or is it just the beginning? Share your views in the comments. Do you agree this is a step forward, or fear it's not enough? Let's discuss.